Very good afternoon, everyone, and thank you very much for joining us today. My name is Nikhil Vaswani, and I'm a junior consultant at Turner & Townsend, and today we're very kindly joined by Dr. Richard Miller from Miller Klein Associates Limited. This is a retrofit information support and expertise event, which is fully funded by the Department of Energy Security and Net Zero, and is delivered by Turner & Townsend. This will be a relatively short presentation, followed by plenty of chances to engage in a Q&A with the speaker. The event will be an hour long and we will finish on time. May I please request that you keep your microphones muted and cameras switched off during the presentation. The slide deck shared on screen today will be made available in a follow-up email after the event to all attendees. Similarly, there will be a clean recording of this and all other masterclasses in the resources section of the RISE website. I will shortly provide a series of useful links in the chat, one of which will take you to those resources. May I please also request that any questions be posted in the chat function as we go along, or alternatively, should you prefer, you may come on screen to ask a question directly after the presentation. Finally, there will be a quick poll and word cloud at the end of the session. May I please request that you complete these as it helps us understand the level of knowledge in our topics. And with that, I'd like to thank everyone once again for joining, and I will now pass over to Dr. Richard Miller for today's presentation on managing your project risk. To you.
Thank you very much, Nikhil, and thank you very much, everybody, for attending. Good afternoon. So today we're talking about project risks and the management of project risks. And as Nikhil said, we're going to go through a fairly brief presentation, I hope some useful detail, and then there'll be a chance for a discussion and a conversation, and we can talk about what's been said. So what we're going to cover today is, first of all, think about why we need to do risk management, understanding the types of risk, developing a risk management plan and the risk register, and then using the risk register for project management. One of the things I've noticed over the years is that the risk register is not taken advantage of in helping a project to keep aligned, keep everything together, keep moving forward. So I'll talk a little bit about that. And we'll talk about a starter for 10 for project risk, just for you to get you thinking about it. So why do we need to worry about risk management? It looks like extra work. It just feels, it's often seen as useless bureaucracy, but it's vital and it can be a powerful project management and communication tool. So a lot of people see it as something, well, we just got to do it because it's in the rules, our funders want it, our senior management want it, whatever, we just got to do it. It can be much, much more than that. It can be much more useful than that. And it is one of the things that I have observed in projects, not only these kind of retrofit projects, but in many other projects, that is generally not done well. Sometimes it's barely done at all. So thinking about risk helps you deliver a better project. So first of all, some examples of people not getting risk right. So this is the Airbus A380. It came into service in 2007 after major delays. It's a very complex plane, has 100,000 different wires covering 530 kilometers in a single plane and performing over 1,000 separate functions. When they tried to install the wiring looms into the first airframes, they were too short. And fixing that problem cost over $6 billion in delays and additional costs. How could such a mistake be made? Well, the aircraft design was a collaboration between 16 sites across 4 countries. Computer-aided designs for various subsystems were shared and integrated into a digital mock-up of the final aircraft. That should have meant that everyone was working to the same design all the time. Unfortunately, different design groups used different versions of the same CAD system. It was the same CAD system with the same standards, but they were using different versions. And the different versions used different algorithms for calculating the length and bend radius of the wires. As a result, When everything was integrated into the final digital model, it looked fine, it looked okay, but on the factory floor, it wasn't. And that decision to allow engineers to use different software versions for speed and familiarity, making it easier to run the project, ended up costing billions. Here's another one. This is the NHS IT system. Started in 2002, it was the largest public sector IT program ever attempted in the UK. It was cancelled in 2011, having failed comprehensively at a cost of over £10 billion. So what went wrong? You can see as we go through the list of what went wrong, some of the risks that were not considered. The project did not consult key stakeholders on the real needs. And in their rush to delivery, there was an unrealistic timetable, insufficient preliminary work, and a failure to check progress against expectations or to test complete parts of the system. For quick delivery, the government opted for a highly centralized program, and perversely, this ended up slowing everything down. The specification for the project was never actually finalized, and this led to many project variations that added cost and time. Effectively, they were designing what they were going to do whilst they were trying to deliver. This project is a lesson in what happens when you make no allowance for known risks and have no backup plan. I think you'll agree that some of the things that went wrong kind of like, well, didn't you think about that? Trying to go fast, trying to make it simple, ended up making it go wrong. Moving a bit closer to buildings and retrofit, what we have on the left is a picture of the Ronan Point disaster. In 1968, one of the residents in this newly opened tower block went to the kitchen to put the kettle on the gas cooker to make some tea. As she struck a match, there was an explosion that blew out one of the walls of the flat. Since this was a structural load-bearing wall, all of the flats above collapsed. 4 people died and several were injured. It wasn't even a particularly big explosion. The lady was blown across the kitchen away from the failing wall and survived. She even managed to take the cooker with her to her next flat and used it for many years. And it later turned out that these walls were not strong enough to survive a good storm. Somebody did not think through the risks or do the calculations properly. And that ended up changing the way we designed buildings, particularly high-rise buildings. And of course, on the right is Grenfell Tower. And the public inquiry has already identified many risks that were not considered, were downplayed or ignored. So getting the risk right is a really important part of thinking about your project, planning your project, and then executing your project. And there are 2 things here that sometimes get brought together and they really don't fit together. It's important to separate the risk management plan and the risk register. The risk management plan is about how you will identify risks, assess their impact, and plan and manage efforts to reduce those risks. The risk management plan is all about how you're going to do it. It can be generic. It can be applied to all your projects. The risk register is a snapshot of the specific risks on a specific project, how important they are, and what you're going to do about it. So the risk management plan covers these issues. How will you assess the risks? Who's responsible? Who's actually going to do it? When will you review and update? Don't assume the risks are all going to stay the same. So what is the plan for regular review, updating, keeping it live? How will you decide on mitigation actions? And who will deliver those mitigation actions? It doesn't need to be complicated. Written down, agreed, and understood by everybody. Because everybody's going to have an input to this, to understanding. Who's got to check the risk? Who's going to update the plan? Who's going to update the risk register? How often are you going to do it? What's the process when you identify a risk for deciding what you're going to do about it? and who's going to be responsible for taking any mitigation actions. The risk register is that snapshot of the project status, and it's a great summarizing tool for that project status. And one of the things I always recommend people do is think about the risk register, particularly something like this single page version that describes what category of risk, what is the risk, how damaging might it be, what are you going to do about it, who's responsible. That can be a very powerful communication tool, circulated regularly to all the key players in the project, not only internally, but externally as well, your contractors and suppliers, to keep everybody up to date with where the project is at and what might go wrong and what is going to be done about it. What do we need to focus on? So the risk register is all about thinking about risks in 2 dimensions. What is the probability of the event happening, high or low? And what would be the impact on the project if it does happen, high or low? And then the top right quadrant are risk events that are likely to happen, and if they do, they will be very bad for the project. These are your high priority risks. The top left and bottom right quadrants are high probability and low impact, or low probability and high impact. So you'll have to worry about these, but these are not quite so urgent to address as the high. And the bottom left are low probability and low impact. We may not be able to ignore them, but they're less of a worry and need less monitoring. And the goal is to push down the probability of a risk happening, and if it does happen, pushing down its impact. So it's contingency plans, it's mitigation, it's avoiding certain things happening, it's keeping on top of particularly delicate parts of the project that have the maximum chance of creating a risk. And these are some of the categories of risk you need to think about. Technical. Will the solutions we come up with actually work? Commercial. Can we deliver the benefits expected and planned at the price predicted? Financial. Can we secure the money needed for the project? Legal and reputational. Are there any legal risks or events that could damage our reputation? Stakeholder risks. Could disgruntled stakeholders disrupt the project in any way? Right? You might have a supplier who's being difficult, a contractor who's not working as you would hope, perhaps working to rule, maybe sticking to the letter of things when a change needs to be made. Those kinds of things. Your tenants. They're an important stakeholder group and they can actually block things happening, not giving access, being awkward. Regulatory barriers that we haven't thought about. Practical matters in the delivery. Could something go wrong in the project delivery? This is where your time risks often come in. And then performance. Once the project is completed, will it deliver the expected performance? So the first step in building a risk register is to brainstorm what could go wrong. You need to involve as many different project partners and teams as possible to get those different perspectives. This is about going as wide as you can, trying to think of everything that could go wrong. This is the initial capture of where the risks lie. And this is something you can tell. I mean, I have looked at hundreds of risk registers from projects and risk plans. And one of the things you can immediately tell is whether this part of the process was taken seriously. Once you have your big collection of risks, start to sort them by probability and impact. And you can talk about the risk, what's its probability, what's its impact, high, medium, low. You can score it numerically or give it a color coding. And then critically, what's the mitigation plan and who's going to deliver it. And when thinking through the potential impacts, it's important to look beyond the direct impacts on the specific task. What about consequential impacts? How could it affect other parts of the project? Like a racing car crashing, a failure of one component changes the handling and steering, causes the car to hit a barrier, damaging more parts, and so on. A cascade failure. So it might be that sudden inability to get a timely delivery of critical parts for your retrofit program has knock-on effects in terms of delays and costs to other parts of the program, your void plan, moving people around, getting people temporarily out of properties and back in again. So a simple problem in a local area, like actually we had a problem installing this component because the parts we ordered when they were delivered and we tried to fit them, they were slightly the wrong size. These failures can be hard to spot and need someone with an overview of the whole project. And very focused teams looking at their particular part of the project, working in silos, can make the problem worse. And if we think back to Grenfell Tower again, certain fire breaks were left out because the materials weren't available at the correct time. And partly also because the people doing the installation were not sure what they had to do and installed the fire breaks that were there incorrectly. The cascade failure there is 80 deaths and a catastrophic fire. So cascade failure is a real thing. Once you've assessed the probability and impact, you know whether this particular risk is high priority or not, and then you can work your way down deciding your mitigation plan for each one. How can you reduce the risk? Can you reduce the probability, or can you reduce the impact? And just to emphasize, this last column in the table is important, but often gets forgotten. Who is accountable for that mitigation plan? If you don't know who is accountable, you may have written something in here, but if there's no person assigned to it, how will you know whether it has been done? Really, unless there's a name here, then there is no mitigation plan. Internally, it's worth combining this column of the risk register with something called a RACI chart, which has been discussed in some of the other workshops, and there's information on the website about how to use it. But just look up RACI charts, RACI, and that will help you with this issue of managing who and thinking through the tasks that need to be done. And the risk register must not be static. It is not something that is done because the funders require it, and once the application is in and been approved, you never have to look at it again. Your project is constantly changing, and so the risks will change. Both the probability and impact events change as new information becomes available. It's a living document and must be constantly updated. And that makes it great in project communication because it is a snapshot of where we are today. And as people get into their tasks, so the plan is done, everyone's been part of the process of planning the project. Now we divided up the work. Okay, you guys do this bit, you guys are responsible for this bit. As people get into their tasks, they get their heads down, they focus on delivery and stop paying attention to the rest of the project. So one of the tasks of project management is to keep reminding people what is going on, where we're up to, what's changing. And that's where the risk register can be an important part of that process. Because what happens in many projects is the kind of centrifugal force forces parts of the project apart. If people are not constantly being communicated with, if they are not being provided with the information and reminded what's going on in the rest of the project, then they just do their bit and gradually that becomes separated from and divorced from the rest of the project. And all of a sudden you find that people are arriving at the wrong times to do different parts of the work, resources aren't available, people aren't available, all kinds of problems emerge. And that kind of falling apart of projects is a very common thing seen in projects which take time and involve multiple teams. So an initial starter for 10 of risks relevant to large-scale retrofit projects. This is not an exhaustive list, and you have to think hard about the specifics of your own project in your own situation. But getting approvals, internal approvals, planning approvals, utilities, highways, the things that you have to do. Project management, budget, timing, procurement, making sure they happen at the right time. everything works. Governance, decision making, management of funds, hope it never happens, but potentially dealing with fraud. Your supply chain, will the materials and manpower be available when you plan? What are you going to do if it doesn't? What happens if the skills of the people you have available, of the people deployed by the contractor, are not up to the job? Dealing with people, dealing with residents, dealing with neighbors, dealing with leaseholders and right to buy in properties that have been sold under right to buy. How do they fit in with that project? How are you going to engage with them? What is the risk of them saying no? We've all seen retrofit projects in which a nice kind of row of terraced houses are being retrofit to a beautiful standard, and then right in the middle of it is one property which is just the way it was before the retrofit program started, because it was bought under right to buy, is now owned by a private landlord who's not remotely interested in your plans for improving the energy efficiency and performance of the property. Design issues, the cost, the performance, dealing with specific issues like ventilation and damp. One of the reasons that PAS 2035 came into existence and is now mandated for all publicly supported retrofit programs is that repeatedly local authorities, housing associations working on retrofitting social housing were ending up with properties that were damaged and difficult to live in because the job wasn't done right. That's where PAS 2035 comes from. So there are real risks in getting unintended consequences if the work isn't done correctly. And that leads on to installation risks. Has it been done incorrectly? How is the QC going to be done? How are you sure that the work is being done to the right standard? What about the risk of rework, having to strip it out and do the job again? During the handover, communications with the residents, snagging issues, resident awareness of how to use things. Yeah, if you've gone for low carbon heating and energy efficient insulation, then you operate that house differently to if you have poor insulation and a gas boiler. So making sure that everyone understands, the repairs and maintenance team understand what's been done and how things need to be operated differently. Your tenant team who are talking to the tenants know the changes that have been made. And then finally, monitoring the performance after the event, which again is part of PAS 2035 requirements. It's good practice. So you need to monitor that the retrofit has worked. That means getting access. That means worrying about performance gaps and what you're going to do about them if you find them. And it means thinking about user satisfaction. So pulling it all together, unmanaged risks can completely derail your project. Funders, whether they're internal funders, commercial funders, government funders, are likely to want to see your risk management plan and risk register. And as I said, I have looked at hundreds of these plans for projects, and this tends not to be a good part of the application. Other parts of the application may be fine, but as soon as you hit the risk register, you can see that they've not really thought about that. It's kind of, yeah, we'll do that later. No, it needs to be part of the planning. You need to brainstorm ways your project could go wrong, sort those ways by probability and impact, and then think about how you can reduce those risks or have a backup plan. And who is accountable? Who's going to deal with it, both in managing the risk register, but also dealing with the individual mitigation plans. If there's no name against the action doesn't exist. And risk registers are dynamic. They're not static. They're constantly changing because the project is changing. And so you have to rethink, just as you have to rethink part of the project delivery plan, you have to be thinking about the risks at the same time. And then please use the risk register as a communication and management tool. It's very, very powerful. And if you have a risk register which is kept up to date, which is regularly updated. It can be part of the routine rhythm of your communications, and then it helps hold the whole thing together. Because everyone looks at it and goes, okay, yeah, see that their risk on this part of the project has become a higher risk event. How does that impact me? Does that mean I have to think about my risks? Do I have to have a contingency plan for if that delay happens or we have to rework some of the project? So that's a gallop through the topic. And now I'd like to open it up for questions and comments. So I'll